Welcome to class number 1 of our Commercial and Industrial Refrigeration course. Before we begin, it is important to differentiate the two major fields where these systems are applied. Commercial refrigeration, medium capacity equipment used in supermarkets, restaurants, refrigerated display cases, and small cold rooms. Industrial refrigeration, high-capacity systems designed for production processes, large-scale storage, and continuous operation under demanding conditions. In this first class, we will study the classification of compressors, based mainly on how the compressor motor assembly is built and sealed, as well as the level of accessibility to their internal components. Under this criterion, we find three fundamental types: hermetic, semi-hermetic, and open. 1. Hermetic compressor. Definition: the compressor and the electric motor are enclosed inside a completely sealed and welded metal shell, which cannot be opened for internal repairs. Main characteristics: in medium-capacity equipment, several hermetic compressors can be installed working in parallel. Does not allow internal maintenance. In case of failure, the entire unit must be replaced. The fully sealed design reduces leaks and lowers noise levels. The motor drives the compression elements, pistons, scroll, or rotors inside the shell. Advantages: no external leaks, quiet operation, relatively low cost. Typical applications: light commercial refrigeration, refrigerators, display cases, coolers, and compact equipment. Types of hermetic compressors: hermetic piston, reciprocating. The most common in small and medium-size equipment. They are efficient, simple, and compatible with many refrigerants. Hermetic rotary. Ideal for compact equipment and light commercial applications. Quiet and small in size. Hermetic scroll. Increasingly used in medium-capacity commercial applications. Known for high efficiency, low vibration, and excellent energy performance. Remember that in the video description you will find the link to the evaluation for this class number 1, as well as more details on this topic. Most common refrigerants in hermetic compressors: R134A, R600A, R290A, and in larger systems, R404A. Typical power ranges of hermetic compressors. Approximately. Reciprocating, piston, from 1/12 HP up to 7 HP, 5.2 kilowatts. Some special models can reach approximately 10 HP. Rotary, from 1/5 HP up to 3 HP, 2.2 kilowatts, with exceptions up to 4 to 5 HP. Scroll, 5 to 12 HP, 3.7 to 9 kilowatts. Some special models reach approximately 15 HP, but for larger capacities, semi-hermetic or screw compressors are usually used. 2. Semi-hermetic compressor. Definition: the compressor and motor are inside a metal housing assembled with bolts and removable covers. This allows it to be opened for internal maintenance. Main characteristics: full access to the interior for repairs. Allows replacement of coils, valves, pistons, gaskets, and other components. Designed for continuous work and high durability. Advantages: fully repairable. Longer service life. Ideal for heavy loads and prolonged operation. Typical applications of semi-hermetic compressors: commercial and industrial refrigeration, cold rooms, supermarkets, and compressor rack systems. Types of semi-hermetic compressors: semi-hermetic piston, reciprocating. The most common. They offer high power and allow internal maintenance. Semi-hermetic screw. Used in larger capacity systems. Provide continuous flow, high efficiency, and very low vibration. Semi-hermetic scroll. Although less common, they are an alternative for medium-capacity refrigeration applications. Most common refrigerants in semi-hermetic compressors: Because they are mostly used in medium-capacity applications, they generally do not use flammable refrigerants, since these systems require a larger quantity of refrigerant in the circuit. The most used refrigerants in semi-hermetic compressors are R404A, R448A, R449A, R407F, R407A, and R134A. Power ranges of semi-hermetic compressors. Semi-hermetic piston, usually between 5 and 70 HP. Semi-hermetic screw, from 50 HP up to more than 500 HP. Remember that in the video description you will find the link to the evaluation for this class number 1, as well as more details on this topic. 3. Open compressor. Definition. The motor is completely independent from the compressor. Both are connected by a belt or direct coupling. The compressor shaft passes through the housing and uses a mechanical seal to prevent leaks. Main characteristics. The motor and compressor are separated. The motor can be electric, diesel, or another type. Motor maintenance does not affect the refrigeration circuit. Higher leak risk due to the mechanical shaft seal. Advantages. Maximum accessibility to all components. Makes motor repair or replacement easier. Ideal for high-capacity systems. Typical applications. Heavy industrial refrigeration. Industrial processes, cold plants, and equipment with high-power motors. Types of open compressors. Open reciprocating. Widely used in industrial applications due to durability and ease of maintenance. Open screw. Common in freezing tunnels, processing plants, and systems using ammonia. Open centrifugal. Found in large refrigeration plants and very high-capacity industrial chillers.